All right, so for today, like we said, we're going to go over the learning intention again, just so that we know what we're doing. So our learning intention for today is we're learning how to solve one-step equation, and we're focusing on the standard 8EE7. And then continuing on that learning intention, I'm going to introduce learning or going over two-step equations, but also introducing multiple step equations with variables on both sides. In order to be successful with this, we got to understand what an equation is. We're going to have to know how to do arithmetic operations, and then we're also going to have to understand when and how to use the additive and the multiplicative inverse. So the first couple of things on here was reviewing the one-step and the two-step equation. And we went over some examples on here. I'm gonna leave this up for 2 seconds. 1, 2, so that you see it. And keep in mind that you could always go back and replay this video. We also went through some two-step equations. This is one of them. I'm gonna leave this up. If you want, you could pause it. I'm gonna leave this up for 2 seconds. 1, 2, you could always go back and look at that. This is another example, all right? Just so that we understand what we're doing with two-step equations. Again, our learning intention is solving one-step equations. We've been doing it for a while, so I decided, oh, why not introduce some multiple step equations as well? So we could see how multiple one-step equations combine together. It's a blank page. So this is where we start. We're going to look at solving multiple step equations when there are variables on both sides. This is where you get your pen and your paper and you start writing. All right, remember you could pause. Where's the pen? Remember you could pause if you need to. All right, so we're solving. Let me write the title. Oh, I can do a text. Solving multiple step equation with variables on both sides. And when we say both sides, we're talking about both sides of the equation, the equal sign, all right? Because you know you have the equal sign, and then sometimes you have x on this side, sometimes you don't. So that's why we're going to look at those. All right, so let's start with the example 2x minus 4 equals x plus 6. All right, so we have this example, and we talked about combining like terms as well. So with this, we're gonna have to figure out how to get all my x on one side, x's on one side, and everything else on the other side. Because when we're doing examples with combining like terms, we want all the like terms that have x's, and without x's, we want them to be together. So in this case, if you look at it, we really want to get this 2x and this x together, because they're like terms, and we want to get this -4 and this +6 together because they're like terms. So it's telling me that I have to move this x on this side and this -4 on this side, or vice versa, whichever way, as long as they're all together. So with the additive inverse, we learned that in order to move items from one side to the next, we have to do the additive inverse, which means we're changing the sign of what it is. For example, I'm trying to move this -4 over here. So in order to move the -4 on this side, I have to do a +4. Does that make sense? Oh, what's happening to the 4? I lost the leg. Bam, there it is. So I have to do a +4, because the opposite of -4 is +4 if I'm doing the additive inverse. All right, so then whatever I do on one side, sure enough, got to do it on the other side. All right, so I'm going to put my +4. I need my color to be blue. There it is. I put my +4 underneath the 6. All right, I'm not going to put my +4 underneath the x, because if I put my +4 underneath the x, They're not like terms. Remember, I want my like terms to be together. Then we're going to simplify. This right here is 0. The additive inverse is always equal to 0, period. All right? There's no questions, no comma, no pause. Always equal to 0. So then this right here is 10. So if I'm going to simplify, I'm going to have 2x is equal to, I don't need to put the 0 because why? It's 0. 2x is equal to x plus 10. Look at that. Now my next step is to get this x on this side, on the equal side. So in order to do that, I need to do a minus x. This is a positive x, and this, so in order to get it on the other side, I need to do the additive inverse, which is minus x. And whatever I do to one side, sure enough, got to do it on the other side. Minus x. All right. So now we simplify again. We already know that the additive inverse is always equal to 0. So this right here, 0. And then we simplify it where we have 2x minus x. If you have 2 x's and we're minusing 1, we have 1 x left, all right? We have 2 apples, and we have 1 apple here. And we're going to minus an apple. We're going to be left with 1 apple. 2 apples, and we're going to take away 1 apple. 1 apple is left. So if we have 2 x's and we're going to subtract 1, we're going to have 1 x left. And that's equal to, remember this is 0? That's equal to 10. So x is equal to 10, all right? That's how you solve a math problem where you have multiple variables on either side. Let's do one more problem together. Let's say negative 2y plus 8 is equal to plus, no, it's equal to, let's do 7y minus 2. All right, again, the first thing I want to do, I want to get my like terms together. Right now, they're on separate sides of the equal sign. We need them to be on the same side of the equal sign. So I'm going to move this 7y over to this side. In order to do that, I need to do the additive inverse. So since this is 7y and it's a positive, I'm going to do a minus 7y. Whatever I do on one side, sure enough, got to do it on the other side. So then now I'm going to simplify. This goes to 0. All right. So on this side, minus 2y minus 7y is minus 9y. All right. So plus 8 equals, this is 0, so I have negative 2 left. And negative 2y minus 7y is negative 9y. Refer to the number line video to figure out how we got negative 9y. All right. So now we need to get this 8 on that side. All right. So since it's a plus 8, I'm going to do a negative 8. The additive inverse. And whatever I do on one side, sure enough, got to do it on the other side. Right here, we know that the additive inverse is always equal to 0. So 8 minus 8 is 0. So we're left with minus 9y is equal to negative 2 minus 8 is negative 10. All right, negative 2 minus 8 is negative 10. So this is negative 10. So then my next step is to get y by itself. All right, that's what's the goal. I'm trying to get y by itself. So I'm going to do the multiplicative inverse. So I'm going to move this question up here so that we could see it. So it's minus 9y equals minus 10. And if I'm doing the multiplicative inverse, since negative 9 is multiplying by y, the multiplicative inverse for minus 9y would be dividing it by negative 9. And whatever I do on one side, sure enough, got to do it on the other side. All right, so then y This right here is 1, because the multiplicative inverse is always equal to 1. So this is saying 1y, or y, either one. So now y is equal to negative 10 over negative 9. But I could simplify this, because a negative divided by a negative is a positive. So this is really saying positive 10 over 9. You could leave your answer like that, or you can write it as a mixed fraction. So it's 1 and 1 over 9. Cool. And with that, that's how we do multiple step equations with variables on both sides. We try to combine the like terms, all right? In order to do that, we have to move variables from one side to the next, and all the other numbers without variables from one side to the next. And we do that using the additive inverse and the multiplicative inverse. Remember, you could always rewind, pause, play the video so that you understand what is happening on this. Thank you for tuning in.